solve numericals on van der Waals equations. 1 mole of CO2 was found to occupy a volume of 1.32 liter at 48 degrees centigrade. Calculate the pressure exerted by the gas using ideal gas equations. Second is van der Waals gas equations with A equal to 3.59 atmosphere liter square per mole square, B equal to 4.27 into 10 power minus 3 liter per mole, and R value equal to 0.082 liter atmosphere per degree per mole. So we have to find this two gas pressure, two equation, that is using ideal gas equation and van der Waals. So this is the ideal gas equations. For 1 mole pressure equal to RT by V, just use put this value R, T and V. So we'll get answer 19.94 atmospheric pressure. Now similarly, by using van der Waals equations, we can, if you put it, P equal plus A by V square, V minus P equal to what? This is van der Waals gas equation. So P equal to P, so this is van der Waals gas equation. So P equal to RT by V minus B minus A by V square. So just substitute the value R, this is RT, this is V minus B, and this is your A by V square. So on solving, this will equal to 20.682 and minus 2.06. So on solving, you will get 18.5848. So this is the difference of these two gas pressure. This is the ideal and this is the van der Waals gas. So this is just nearly, it agrees the this value is values agree with the values of the ideal gas equation. So two values just close agreement. Now second questions. Calculate the average volume available to a molecule in a sample of nitrogen gas at NTP. So what is the average distance between the neighboring molecules if a nitrogen molecule is assumed to be spherical? So we have to find the volume of first volume of occupied by actually one nitrogen molecule. So this is the molar volume of the nitrogen molecule. This is the volume of the nitrogen molecule at STP. So this is your at STP, external temperature and pressure. So this is the volume divided by the number of molecules. We'll get the one volume of molecule. Now let R the radius of the nitrogen molecule. So volume of the one molecule will be 4 by 3 pi r cube. So this is the some nitrogen gas which have nitrogen molecule which have two molecules. This is the R, this distance is the R. So R cube will be 3 by 4 into 7 by 27 into 3.72 multiplied by 10 to the power minus 22 minus 20. So on solving, you will get the centimeter cube, R equal to 2.07 into 10 to the power minus 7 centimeter square. So distance between the neighboring molecules will be 2R. That is, on solving, you will get this. This is our answer of this question. Calculate the temperature of a gas if it obeys van der Waals equations from the following data. A flask of 25 liters contains 10 moles of a gas under 50 atmosphere. Given A value 5.46 atmosphere liter square per mole square and B equal to 0.031 liter per mole. So using van der Waals equations, this is our equations. Substitute the value. On substituting, this is the 50 and this is your 10 plus square. Just 10 square plus 5.46 divided by 25 square. So on solving, 25 minus 10 into 0.031 and 10 point equal to 10.0.081 into temperature. So on solving, we will get the temperature T equal to 15.29.93 Kelvin, or in centigrade, this is our value. Out of ammonia and nitrogen, which will be having larger value of A and larger value of B. So in case of ammonia, intermolecular force of ammonia is higher than the intermolecular force of nitrogen. So why it is higher? Because they also do hydrogen bonding. So due to which what happens, the force of molecule becomes larger. So hydrogen bonding, due to hydrogen bonding, their force of interaction is increases. Now in second case, if you take which a larger value B is nitrogen having the B value is larger. Why B value of nitrogen is larger? Because size of the nitrogen molecule is larger. That's why it is had a greater van der Waals constant. So size of the B molecule larger than the ammonia. Given that the co-volume of oxygen is 0.0318 liter per mole, so calculate the radius of the oxygen molecule. So co-volume is 0.0318 liter per mole, change into centimeter cube per mole. So on changing, so you will get 31.8 centimeter per mole. Now B equal to what? So B equal to your 4 into Avogadro number into volume. So this is the 4 into Avogadro number into 4 by 3 pi r cube. So this is the B. So on solving, you will get r cube equal to 3.153 into 10 power minus 24 centimeter cube, or r equal to 146.6 picometers. This is the value on solving. So one unsolved problem. So 1 mole of a sulfur dioxide gas occupies a volume 350 ml at 27 degrees centigrade and 50 atmospheric pressure. So calculate the compressibility factor of the gas. Comment on the type of deviation shown by the gas from ideal behavior. So on solving, you will get Z equal to, this is the compressibility factor equal to 0.711 and negative deviation. So just use the van der Waals gas equation, that is Z equal to P by RT. Put this value, P is given, value is V is given, R is given, T is given, and you will get the Z value. This is the value of this answer.